Project 802 defines an architecture for local area networks that specify services and protocols for the physical and data link layers of the OSI model. The IEEE Project 802 architecture divides the OSI data link layer into two sublayers, the logical link control sublayer and the medium access control sublayer. The Logical Link Control, or LLC sublayer, provides services to the network layer above it in the same manner that a conventional data link protocol does in a wide area network. The LLC sublayer provides many of the same services to the network layer that modern wide area networking data link protocols provide, such as ISO's High-Level Data Link Control, or HDLC. Functions operating at the level of the LLC sublayer also employ a similar data unit format as HDLC. The IEEE LAN architecture defines two aspects of the operation of each layer and sublayer: layer and sublayer services and peer-to-peer protocols. Layer and sublayer services describe the interactions that take place between adjacent layers in the same station. Logical Link Control sublayer services consist of those services that an LLC entity provides to a network entity above it. They define the interface between the network layer and the LLC sublayer and describe the functions that a network entity can request of an LLC entity. Medium Access Control sublayer services are those services that a MAC entity provides to an LLC entity. They define the interface between the LLC sublayer and the Medium Access Control sublayer and describe the functions that an LLC entity can request of a MAC entity. Physical layer services define the interface between the MAC sublayer and the physical layer. Peer-to-peer protocols operate at each level of the architecture. A peer-to-peer protocol defines two things: the formats of the data units that are exchanged at a particular level of the architecture, and the data flows that take place in exchanging those data units. At any level of the architecture, a layer or sublayer entity appears to transmit a data unit called a protocol data unit, or PDU, across a virtual connection to a complementary layer or sublayer entity in the distant station. A layer or sublayer entity actually requests a data transmission service by passing its protocol data unit down to the layer or sublayer below it in the form of a service data unit, or SDU. When a layer or sublayer entity receives a service data unit from a higher level layer or sublayer, it adds protocol control information, or PCI, to the SDU to create its own protocol data unit. There is often a one-to-one relationship between the SDU that a layer accepts and the PDU that it creates. However, if a particular layer or sublayer entity supports a segmentation function, it may package a single SDU in the form of multiple PDUs, which are then passed across the network individually. Because protocol control information is added each time the data unit is passed down, each layer and sublayer works with a different protocol data unit. A network entity in this station appears to transmit a network protocol data unit, or NPDU, directly to a network entity in this station. An NPDU is often called a packet. The LLC and MAC sublayers also have their own PDU formats. A logical link control entity accepts the NPDU that was passed down to it from the network layer in the form of an LLC SDU. It then adds control information to create an LLC PDU. The LLC SDU within the LLC PDU is treated as data by the LLC and MAC sublayers. A medium access control entity then adds its own control information to create a MAC PDU. The MAC PDU is often called a MAC frame. The PCI in a MAC frame takes the form of a trailer as well as a header. Peer-to-peer protocols describe the interactions that take place between complementary layers in two communicating stations. These are defined in terms of data unit exchanges that involve the transfer of both data and control information. A separate peer-to-peer protocol operates between pairs of the network layer, the LLC sublayer, and the MAC sublayer. The peer-to-peer protocols described in this course are those that operate between LLC sublayer entities. Data flows through the layers and sublayers as stations exchange messages. A network entity in Station A passes a packet down to a logical link control entity in the form of an LLC SDU. The LLC entity adds protocol control information to the LLC SDU to create an LLC PDU. The LLC entity passes the LLC PDU down to a MAC entity in the form of a MAC SDU. The MAC entity adds its own set of control information to the MAC SDU to create a MAC PDU, or MAC frame. The MAC entity uses the services of a physical layer entity to broadcast the MAC PDU into the network. Protocol control information in the MAC frame contains the address of the station that is to receive the frame. This station examines the control information and detects that the MAC PDU is intended for it. A MAC entity there accepts the MAC PDU. The MAC entity strips off the PCI from the frame, creating a MAC SDU, which it passes up to the appropriate LLC entity. The LLC entity accepts the SDU, strips off its set of control information, and passes the resulting LLC SDU up to a network entity, recreating the original packet. In some LAN applications, a single station can be involved at the same time in multiple data exchanges with other stations. In order to distinguish between different exchanges that involve the same station, the term Service Access Point, or SAP, is used to identify a particular element within a network station that is involved in a single data exchange. A service access point can be thought of as a port or access point to a higher level layer within that station. Here, a separate logical link control entity handles communication for each service access point. Service access points can be used for any desired purpose. A separate service access point is used in this example to address each of the terminals attached to this station. Here, service access points are used to address different application programs that are running in the device. A service access point that sends a data unit is a source service access point. A service access point that receives a data unit is a destination service access point. Each service access point has an address that uniquely identifies it within the network station. The format of the header that is attached to each MAC frame is slightly different for each form of medium access control, but the header always includes the station addresses of the destination station and the source station. Station addresses are often called MAC addresses. The service access point address specifies a unique point of access to the logical link control sublayer in a particular station. The station address distinguishes a particular communicating station from all other stations attached to the local area network. Each station on the network must have an address that uniquely identifies it. Addresses can be either 16 bits or 48 bits in length. For a source address, the first bit of the station address is always 0. For a destination address, if the first bit of the address is 0, the address is for an individual station. If the first bit is 1, the address is a group address. An address of all 1 bits is the broadcast address and addresses all the stations on the LAN. All other group addresses refer to logical groups of stations that are defined when the LAN is configured or by some convention defined in a higher level layer. IEEE Project 802 has defined 2 forms of addressing: locally administered addressing and universal addressing. All 16-bit addresses are locally administered. For 48-bit addressing, if the second bit is 0, addressing is universal. If the second bit is 1, addressing is locally administered. When locally administered addressing is used, it is the responsibility of the organization installing the network to assign a unique address to each network device. With universal addressing, addresses must be 48 bits in length, giving 46 bits for individual station addresses. A 46-bit address provides enough addresses so that every device that is manufactured anywhere in the world can be assigned a unique address by its manufacturer. The IEEE, operating on behalf of ISO, assigns different blocks of addresses to each manufacturer, who then assigns addresses from that block to the devices it manufactures. You have now seen how the logical link control sublayer works by looking at 3 aspects of IEEE Project 802 layer and sublayer operation, the data flow that occurs as stations exchange data units, how service access points serve as addressable ports into the LLC sublayer, and finally, how individual stations and groups of stations are addressed. Please turn to Mini Course 3 in your personal reference guide and continue your study.